Alright. So, this one's asking us to curved arrows, oh I wish you couldn't see that, to the reactants to indicate movement. So apply curved arrows to reactants to indicate movement of electrons in reaction. Okay, so with that being said, we have this formula here: NH3 plus HCl, okay, turns into NH4 plus Cl minus. Okay, so first we just have to do a quick glance at this all balanced equation, which it is, and then what we need to do actually is draw out the molecules for each to kind of see what's going on here. So we have NH3, right? Whoops. So we have a nitrogen with a double bond here, and we have 3 H's. Okay, and then we have HCl, which is bonded like this. Okay, right? And now we want it to turn into the NH4 okay, and we want to also have the Cl minus, okay, and it's NH4 plus. Alright, so with that being said, NH4 plus and Cl minus, NH4 plus, how would this happen? So with this you have to watch really closely. Okay, so nitrogen has 1 lone pair, okay, and chlorine is turned into an ion with 4 lone pairs. So from 3 lone pairs to 4 lone pairs, meaning that this bond here, right, starting with the chlorine, has to go from the hydrogen to just, as in from being shared to just being hogged by the chlorine. Okay, that's just what's going to happen here. So in a sense, chlorine says, sucks to be you, hydrogen, I'm taking your electrons, the electrons we were sharing, and it's all mine now. So instead, we do have a hydrogen technically, but in reality it's really just a proton, because hydrogen has a atomic weight of like around 1, which in case it's 1 proton, and typically only has 1 electron, but that's what it was sharing with the chlorine. So when chlorine takes all that, the 2 electrons that they were sharing, hydrogen is literally just left with just a proton. But nitrogen is like, hey, you know what? I can actually make up for that. I have 2 electrons here that I can share with you, hydrogen. So the nitrogen is going to actually bond directly with the hydrogen. Okay, and in fact, the way I actually explained it would actually be the backwards way it goes. Okay, the nitrogen is most likely actually the way the order goes, because you want to actually, in a sense, kind of be shifting. You don't go, actually I'll just explain it and you'll see my logic here. The nitrogen actually would first go towards that hydrogen and be like, hey, I'm going to share these bonds with you, and hydrogen's like, yeah, sure. Also because nitrogen and hydrogen, those are actually considered like a type of hydrogen bond. So exactly, nitrogen is like, hey, I'm going to share this with you. Hydrogen's like, yeah, sure. Nitrogen tells hydrogen to ditch the chlorine. Hydrogen does so the chlorine's like, okay, whatever, I'll keep the electrons. So with that being said, that's the type of attack that happens, because as you can see here now, if I circle this, I can do better than that. That is the new hydrogen there, and you know, I'll circle that as well to just indicate that. So you see that bond. In fact, let me actually do this, because this bond here technically is still going to be the blue, the blue bond here, okay, and these 2 electrons are actually going to be the green electrons that are forming that bond there. Just that way you can actually at least keep up with the color coordination. Okay, so that's how the nitrogen attacks the hydrogen, and then chlorine keeps its bonds, and that's how we get the chloride ion, and that's how we get this ammonium. Okay, so with that being said, yep, I know you probably saw the picture already, but yes, this is indeed correct. That is how they would attach to each other. Now, question number 16, okay? This question is